Hello everyone, welcome to UrbanSubnet.com. Today we're going to talk about the classes of IP networks. So IP addresses come in various classes. So the classes are divided up based on the network numbers. So we're going to look at the classes of networks here. We have a class A network that has a range of 1.0.0.0 through 127.255.255.255 right here. So this is your class A network range. The network number in a class A network is the number of the first octet, the number in the first octet. A class A network has a subnet mask of 255.0.0.0. Now your subnet mask determines your network prefix in the network IP address. So 255 is the network portion. So the number in the first octet 1 through 255 would be the network numbers. Okay, that could actually be a 0, but there is no 0 network. So but the first octet is the network number. The remaining 3 octets are the number of the computer devices on that network. Now the class A network, of course, is the biggest network class, or it has the largest amount of hosts that can be connected to a class A network. Now the class A network, using the default subnet mask of 255.0.0.0, can connect 16,777,216 individual devices, which makes it a very, very large network. Now, being that the developers and the people who built the internet, who designed it, engineered it, architected it, they decided, well, we don't want to waste addresses. So, giving a company this network right here, 1.0.0 with a subnet mask of 255.0.0.0, will give them this many addresses. So they started to say, that would be a waste of addresses. So they came up with something called a subnet, which would subnet the addresses to smaller subnets. So you have a major subnet with 16 million addresses, but you could subdivide that subnet down to a more reasonable number in this range of addresses. So now they can say divide this network in half, or divide it into quarters, and then give one company the first quarter of addresses, then another company the second quarter, the third company the third quarter, etc., etc. And then they could utilize the addresses and use them more efficiently on the network. That's another video in itself, talking about how you subnet networks and how you comprise and determine the amount of hosts that a network can have once it's subnetted. Now, in the class A network, this would be a valid address. 27.100.100.18 with a subnet of 255.0.0.0 would be a valid address in that class A network range. Okay. Now, in a class A network range, we have 127.0.0.1 is an address that is reserved for loopback adapters, and loopback is mainly your network interface card. So when your computer or server connects to the network, it has a device inside the computer called a network interface card, or a NIC card. And this address, 127.0.0.1, is an address that is used to verify and test that network adapter. To see if that NIC card is functioning properly on your computer, you can go into your command prompt and ping 127.0.0.1, and you should get back 4 replies that tell you that the network interface card is working properly within that computer. So it's used for troubleshooting, actually, that 127 address, that specific address. There's also a reserved network in the Class A network, which is the 10 network. We talked about that in one of my other videos. The 10 network is reserved for private use. No one owns that network number. These other numbers, people own them. They paid for them and they own them. This is basically their property. So, but the 10 network is not for sale. No one owns it, so you can use it within inside your company to assign IP addresses to your devices within your company. These networks, these reserved networks, are called RFC 1918. RFC stands for Reserved for Comments. This is the documents that circulate around the industry when a protocol or something is being developed, and these requests for comments go out to all of the people experienced and educated in these fields, and they comment on these certain things, and they'll say, well, let's reserve the 10 network for private use so people can use that on the internet within their companies. They can't use it on the internet, but they can use it within their companies. So everybody will agree, and they'll come up with these final documents, and they're numbered. And this one, RFC 1918, if you go to your Google and you put this in, you're going to get back a document that will explain to you how, why, and the reasons, etc., for them coming up with the private IP address space. Now, there's another class of networks, the Class B networks, which have network numbers of 128.0.0.0 through 191.255.255.255. So Class B networks will begin with the number 128 and end at 191. Now, Class B networks, the class is the subnet mask size. So in this Class B network, we have a subnet of 255.255.0.0. So in this network, the first 16 bits of the subnet mask is being used for the network prefix. So a Class B network, 175.160 would be the network range, or the network number. It would just be the network number. The 20.6 would be a individual computer on that network. So if you follow this along with me here, you can see our Class A network has the first 8 bits are being used for the network prefix. So the first number is the network number. The remaining 3 octets are the host. On the Class B network, the first 16 bits are used for the network number. So 175.60 is the network, 20.6 is the host, the remaining 2 octets. This is what the subnet mask looks like, 255.255.0.0. And on the Class B network, you can connect 65,536 devices to that network if you use it exactly like during the default subnet mask. If you use it as it is written here, that's how many hosts we can connect to this network here. Now, like the other network, the Class B network, most people will subdivide this network up into different networks, because 65,000 is a lot of devices to have on a network, and it's easier to subdivide the network up. You can manage it better, you can troubleshoot things better. So we're going to do videos in subnetting too, but that's just something to keep in mind, that normally a network this large could cause problems when troubleshooting. What say if device 36 goes down? How do you find it within all of these devices here? You got 65,000 individual computers there, so it would probably be subnetted down to a smaller network. Now, in the Class B range of addresses, we have a RFC 19, which, as we said earlier, is a private address space. No one owns this address space, so anyone can use it. So the RFC 19 address for the Class B network is 172.16.0.0/12. So they use the first 12 bits in the octet, the first 12 bits in the subnet mask for the network portion. Okay, and the remaining bits are used for the host and the computer devices. So in this particular network, this is how it would look. In this private network range, you can use network 172.16, 172.17, 172.18, 172.19, all the way up to 172.31, 255, 255. That is the network range that you can use. So it can be 172.16 through 172.31, and then your remaining host would go on the remaining 2 octets of these particular networks. So I can have a network of 172.19.10.10 would be a valid address on my LAN network using the RFC 1918 address space. So that's just something to remember when you're working with this type of private address space here. And your subnet mask for this address space would be 255.240.0.0 because you're using the first 4 bits in this octet here for your network. So the first 4 bits in the second octet are used for networking. The last 4 bits are used for host address. So we will have to study that, and you can read up on this stuff on the internet, anytime, and find out more information about these RFC 1918 addresses. And you can also go to the RFC 1980 document that is on the internet by Googling RFC 1918 on your computer. Now we have a Class C network, which is 192.0.0 through 223.255.255.255. Now the Class C network is the smaller of the private network ranges, which is ideal for a smaller company that may say we may never have more than 25 people working here. And let's say if you double that with devices, so they may say we may never have more than 50 devices connected to our network at any time. And it would be easy for them to grab a Class C network and use that to number their devices on their network. So with a Class C network, you have a subnet mask of 255.255.255.0. And this subnet mask will allow you to connect 252 computer devices to that network. So a valid Class C network would look like this: 220.10.10.61 with a subnet of 255.255.255.0. This is a valid Class C network. Somebody out there owns this network here, and they may have a device on their network which is 61. So they can connect 252 devices onto that network. The host devices use the last octet. The network number is 220.10.10. That is a valid network number. This is a public address, so that's for the public portion of it. This network can be broadcast or transmitted through the internet as it is, but the private addresses cannot. So as in Class A, Class B, Class C also has reserved private address space that nobody owns that you can use. So in your Class C network, the address that is reserved is 192.168.0.0/16. So that is the address space that is reserved for the Class C network numbering range. Okay, so you could use that 192.168 on your local network to number your computer devices. Hello everyone, we're looking at the Class D networks now, which Class D network is 224.0.0.0 through 239.255.255.255. Now, the Class D network is used for multicast, as you can see right here, multicast. This network range of numbers are used for, how do I say this? It's used to help the network function. In other words, we have routing protocols that use network numbers in this range to communicate with each other. So the routing protocols will communicate with all the routers on the network that are running that protocol in it, or all the routers in the autonomous system. Networks are divided into autonomous systems when it comes to routing. But different routing protocols like OSPF, EIGRP, they use network numbers in this range to communicate with each other. Another big function of multicast is exactly what we're looking at right now. YouTube has servers that send out videos to multiple destinations. The destination is the computer that is looking at the video. So what happens is the multicast videos will have a network number in this range, and you will connect to my computer will send a packet to the YouTube video server saying, hey, I would like to see this video from UrbanSubnet.com, and then the YouTube server will arrange to send that video to that computer based on the computer joining the multicast tree. So that's what multicast IP addresses are used for, to help protocols communicate on the network, to send multicast videos and multicast documents to computers. Because if we didn't have multicast and this video was being broadcast, it could be broadcast to everyone, just like a TV station. A TV station just broadcasts its signal out to the rest of the world. If you want to watch that TV station, you turn your TV on and you tune to that channel, and that is how television is broadcast. It's just broadcast out to everyone. It's up to you to decide whether or not you want to see the broadcast. On the networks, it's similar to that. The multicast video is there, but it is not broadcast to everyone. When you want to see the video, you will send a packet to the video server saying that I want to see this particular video. The video server will then set up what we call a unicast communication between the video server and your computer. And then the video server will send the video to your computer only. And it might be sending it to 100 other computers. But all of those people that are watching the video requested to see the video, and that information is transmitted through the multicast network numbers. So that's what multicast does on the network. And there is books and videos totally dedicated to multicast, how to configure it, how to set it up, how it works, how to understand it, etc., etc. So multicast is a big topic in the networking field. So that's something you definitely would want to Google, read, and understand and study more as you become working network engineer or network IT person in this field of work. And we have the Class E address, which is 240.0.0, 255.255.255.255. Class E network is used for experimental purposes, so you should not see that address on your network unless you're working in a laboratory or some kind of experimental process in the networking field. So that Class E address is reserved for experimental purposes only. So this is an overview of the classes of address. You have Class A, Class B, Class C, Class D, and Class E. And each network class has limitations on the number of hosts that can be connected to the address and the numbers that you can use for those particular networks. There are limitations on the networks, that numbers that can be used, and the number of devices that can be connected. So I hope this gives you a better understanding of the classes of networks that are out there. As always, I want to encourage you to use the internet and go through various websites and get more information. You don't have to go to the library these days for a lot of information that's available to you on the internet. So I encourage you to use the internet for that. You can Google ARIN, the American Registration of Industry Numbers. I believe that's the acronym for that. But that's the institution that assigns these IP addresses out. So you can go to their website and read through some of the documents there. Lots of very good information about IP addresses there. I mean, we're learning about IP addresses, so the more you know, the better it will be for you. You have RFC 2050 and you have RFC 1918. You want to look at those RFCs and just read through them. And reading RFCs can be boring, but there's a lot of good information in those RFCs, especially for people who are learning this for the first time, or still need to learn more information about this subject. And I always encourage you to practice writing out your IP addresses in binary, any dotted decimal form, just to have more experience in that. You probably won't be using binary in the work field, but it'll be good to know just in case. And here's a couple of links. We got a link to the ARIN network. We have a link to whatismyipaddress.com. You can go to that site and it will actually tell you what your own IP address is. So that could be good to know. Or it can also just give you an idea of what things look like and how your computer is configured. And then there's another link here to find the IP address of a website. So if you want to find the IP address of Netflix.com, you can go there and type in the name, and then it will spit out the IP address for you. And I thank everyone for viewing this video, and I hope it was informative for you, and I want you all to have a nice day. Thank you.